G'day, welcome back to the channel. We are going back to fabricating and engineering, which is what we know best. So there's been a few videos that I've put out which have been driving videos, hanging out with the crew, having a good time, but I've done a whole bunch of work that I haven't recorded and I'm a little bit down at myself. I wish I'd made the time now. So we have Baxter's GT86 now. We need to put a roll cage in this car. Being a GT86, there's a lot of them around. A lot of people are using them. They're a good base. You can buy GK Tech everything to, you know, turn into a drift car, time attack car, pretty much anything you want to do. Sprints, hills, everything. They're a good base if you want to build a car on a budget. It'll still cost a decent amount of money, but the simplicity of it is you can buy parts, you can bolt it in, you can go racing. What our job is this weekend is we're going to be building a roll cage. I've got to the point where I've taken a few basic measurements and I've bent the hoop up earlier in the week at work. We are inside the cab now, making provisions for when we put the hoop in. Pretty much what you want is you want to make the hoop touch as much of the external body as possible. The idea is if you can get it right, you can get the radius of the bends right up in the corners. So right up in here, you'd want it to touch the roof and the side here. Then you'll have a little bit of a gap in the B pillar here. You want the base of the leg to be as hard up against this pillar as possible. For now, we're just going to get rid of any little tabs that are currently in the car that are going to be in the way that'll interfere with that hoop. What I can see so far in the 86s are there's a whole bunch of braces everywhere throughout the car that are currently going to get in the way of the hoop. So I've pulled these roof braces out. I can see the hoop interfering with that, and then if you look at it from this angle here, these braces hang down there somewhere, so the hoop's going to be out of the way. Your seat and head is possibly, you know, out here, so you want to get that hoop right up against there. So the next thing I can see is the B pillar has this swage in it, right? So that's perfect if you want to sink a tube into that swage and push it against the body. The problem I can see with that is if you look up into the roof brace up here has the same swage in it, but it's actually offset from this one here. So that makes the hoop painful because you want to either run the tube here or you want to run the tube there, and if you run it here, it's on this edge here, so you're pushing it away from the body, whereas if you do the opposite, it's interfering up here and your hoop's going to be low, which is then going to be an issue when you run your leg. You want your leg to be, you know, up here as much as possible rather than down here next to someone's head.
Bro, what are you talking about, man?
In saying that, there's a fair bit of things you need to think about before you even start and make a plan. What we're going to do is we're going to cut this brace here off level with that seam down the bottom. I'm going to unpick this brace here, which is these two spot welds. That brace will then come out. That will then let the hoop sit nice and tight up in those corners. I always use a cut-off wheel, like a 1mm blade on an angle grinder, and just sit there and kind of color in and grind just at the spot weld until the metal is at the point where it's super thin. You can actually see the metal change color on the spot weld itself, where you get most of the way through it. So if this isn't too hot, I've just put a cut underneath the bottom here. So then you can grab this and it'll just pop off like that. A little bit of a wiggle, so I didn't grind as much on the top as what I normally would. So then all you have is the two tiny little welds sticking out. So you just quickly hit them with a flapper wheel and it's all good. I'm just going to give this a hammer so it goes up there and I can get the grinder in there and wash these two welds out, and then we're laughing back onto the hoop. I've then jumped on the wire wheel for about an hour and I've wire wheeled the absolute crap out of anywhere where I'm going to put a base plate. Then at the back I've worked out where I'm going to run the rear stays to. The strut towers are up there, not up on the tubs like they normally would be. They're down actually next to the rail, this here being the chassis rail. So what that means is you either need to build a structure that ties into the actual strut mount, or you mount them directly to the chassis rail, which is what I'm going to do. The mounting points from here to there are quite skinny on the car. So what that means is where you, let's just say if we were to mount the tube up here and then run down to that rail, the tube is then going to run in on an angle like that. That's a bit exaggerated, but it'll run in on an angle like that, whereas normally you want the stays to come out on an angle. What that does is it triangulates the hoop structure backwards. The strongest way you can actually mount a tube. Anything that's triangulated in engineering is incredibly strong. I'm going to try and push this top radius of the bend of the hoop as far to the outside of the car as possible. So what happens there is the tube hits here, whereas I want it to go a little bit further that way if possible. So luckily for the 86 roof, it goes high in the middle. So if you were to run a tube directly parallel across the top of the roof here, you're going to end up with a 20mm, 25mm gap here in the roof. So that allows me to put a bend in the middle of the hoop here, and then this tube then comes down on an angle, which means I can then push this out a little bit further, and I can then get the tube kind of on the inside of that radius coming down, and it will be more parallel. That will then allow me to put an X brace in the back of it that won't look out of place when you look from the back window in. I think the overall cage then won't look, you know, skinny in the back, big wide in the front. This here is my trusty little test bend. This is the first bend I ever did when I built my bender years and years ago. This bit of tape that's on the front of it indicates where it goes into my bender and where it sits on the die. So all I need to know is when I put that tube in my bender that this has to be in that exact spot for it to work. So an easy way to do it is I put tape on the roof in the center and on both sides. All I need to know in the roof is where those bends need to start before the edge of the tube hits the edge of the B-pillar. Easy way to do it, get your tube like this, stick it up till it hits the roof, move it across until it hits the B-pillar, and then from there, all you need to know is that this part of the tube, you want it to be perfectly parallel with the roof. So as you look at it, you want to be looking at that tube and then clocking this as it hits the side of the car until that looks like it's going to shoot perfectly across to where it meets the other bend. That up against the roof, that up against the B-pillar, lining that up there. I then put a mark on the roof on my little bit of tape. I then mark the center of the car, and then I do the same on this side. So I flip my test piece over, chuck it up on the roof, move that across like so, and then do that same mark. Then what I do is I measure the distance between the start of that bend and the start of this bend. That's all I need to know. So that measurement's written up here. All you need is a big bit of cardboard that you can do a very basic drawing on. From there, I know as long as my bends start there and there on that straight bit of tube, if I overbend this or underbend it, it doesn't matter, that radius stays the same. So it's always gonna hit the side and the top of the roof. Put a straight edge across the roof up here, and I measured the gap between the top of the straight edge and the roof. It was about 25 mils. I'll quickly explain my hoop jig. So this is the one that I've drawn. Pretty much I've just drawn the outside width, the width of where the middle bend's got to be, the width, the height from the floor up to the highest point of the cage, which is the middle up here. I always start off with a square. So I've made this and then this line here perfectly square to start off with. So you draw a perfect square. We know where our bend marks are because of what we put on the roof. So then, once I've got my square, I then measure from here up to the first bend, and then I draw that line in. I stop it there, I don't draw this one yet, because you've got this line that goes across the roof and you know where your bend marks are. So then I stick that there like that until my line lines up, and then I trace the radius of this bend like that. That will give you this line here. Then I know where the edge of the car is without having to do a whole bunch of maths. It's a physical thing. So then I just draw a straight line from here until it hits the outside of that, and then that then tells me what the angle of that bend is, which is that there. And then I do the same thing down here, mark where the bend starts. So once that tube is sitting on there and you've got that bend and that bend, you literally just trace your tube down like so, and then do the exact same thing, and you just imagine that that comes down and then keeps going. That's the physical approach. And then with this one, I'll put a bend in the middle first, and then pulled the tube across and then drew a center line in the middle of that bend. And that's the way I do hoops. It's not all that hard to do. You can do anything like that. You can do bash bars, you can do, yeah, any tube that you need to bend. That's a very quick and easy way to do it. Let's put the hoop in. So as you can see there, the hoop is nice and tight.
Nice.
And it fits quite well. I do want to move it back a little bit because I always try to keep this behind the window. I might actually throw the seat back in and actually see where roughly it sits. So in cams, to cam spec in Schedule J, you want the seat within 6 inches of the hoop. So roughly 150 mil. The hoop sits pretty good where it is. It's not from where I measured it up. It is, looking at that, probably like 70 mil forward. I want to try and get it up and inside this roof brace rather than inside here. Reason for that being is I can still push it up against this part of the brace. When you do a weld in roll cage, you need to be able to drop the cage down so you can weld across the top up here. So where the tubes come off the top here and from the back, you need to be able to weld up and over the top of that to make it super strong. You can bring the hoop forward and drop it down into the floor pan here. Heap of different ways to do it. The way I'm going to do it this time is I'm going to bring the whole cage forward and then drop it down off the pedestals, weld it out, put it back up, weld it to the floor plates. I'm going to cut a little bit more off the bottom of the legs. I'm going to get the base plates in. Now I know the hoop has to go back, but I'm going to have to lower it down so it's not hard up against the roof. The reason for that is if I put it inside that rib, I then won't be able to pull the cage forward to drop it down to weld it. Rear base plates, hoop's now tucked in. I've leant it back probably about 5 degrees to get the top of it more away from the driver's head and the base where I want it in the middle of the B pillar. Relatively happy with how that fits. Normally I would push the corners here hard up against the B pillar. Because of the design of the car, everything seems to be tapered, like it all tapers in. So in order for me to put the door bar in here, I wouldn't be able to slide the cage forward to drop it down into here to weld it. So normally what you do is you bring it forward, ratchet strap the legs together and squeeze it to get it inside here. And then once it's dropped down, I'll then be able to weld the top up here and at the back. Normally you would build the front half of the cage first because it's the part that you need to bring forward and drop down. I haven't made the boxes yet and I forgot to fold the trapezoid gussets up. So what I'm going to do is I'm going to put the 2 rear stays in and I'll leave them on the hoop, but when I bring it forward and drop it down, I've built full cages before and then moved the entire cage, and then when you put it back in, you've got 6 points that you're trying to line back up, so it's a little bit difficult. Also, when you weld it, the cage likes to shrink it. It goes super tense. It's under a lot of weight from the way you've welded it. When it cools down, it pulls. So yeah, you end up getting little gaps around the feet and stuff when you go to weld them, which isn't a problem. It's good for penetration, but it's a pain to get the cage 100% where you originally built it. With the rear stays, what you want to do, educated guess. You know the tube comes up on an angle, so if you sit the tube on it when it's cut at 90 degrees, you're going to have a big gap on one side. Take a guess, cut 20 mil off one side and cut it down on an angle like this. I'll show you what I mean. It's a lot easier than explaining it. Chamfer the end of the tube like that. I actually got this one pretty close to spot on. That's pretty close to perfect. It just needs to come forward, which is perfect because where this is sitting up there, it's going to come forward when we notch it in the tube notcher. So I always line the inside of the tape up on the rear stays of the bend. That's very easy to get it symmetrical from that side of the car to this side. As for measuring degrees when you're notching, super easy. I have a digital angle finder. You can even do it non-digital one, as you can just line it up in your notcher. When you sit the tube where you want it to sit, make sure that your hoop doesn't move off your roof line where you've marked it. And then you just get this and you sit it up on your hoop and then you move it across until it touches both tubes. And then from there, that's the angle that you notch this tube at. So that tells me that that's bang on 90 degrees. So I notch this dead straight. The next thing is your clocking of your tube. So I always keep it in my pocket. Once again, make sure it hasn't moved off the roof line, bring that up. And then I just make a line exactly 90 degrees as to where I want to notch it. So pretty much you want to get this in a straight line with that. If you were to draw a straight line down that tube like that, get this one in the center, and then you are just marking it there. Roughly. Like that. Doesn't have to be pretty. Taking an educated guess, the back of that tube has to come forward, 40 or 50 mil. It will move a lot more than what you notch this at because it's at an angle. So if I take probably 15 mil out of this when I notch it, that will then move forward the amount, because as you make the tube shorter, it comes this way a lot more. Trusty old tube notcher. This is an old Heron Forbes one. Actually, I think I got this one given to me. All I did was machined up a bearing housing here with 2 roller bearings in it, one in that end, one in that end. So that acts like a guide so it can go forwards and backwards as it spins. Battery drill on this end, tube goes in there, and then I just lined this little cut mark up here with your degrees. And that's it. So if you want to adjust your degrees, loosen that bolt there, loosen that bolt, spin it to your degree, lock it up, and you're notching tubes. I'd clamp it to one of the trailers. Now you understand if you've never used one before. Little G clamp, set the notcher at 90 degrees, 44mm hole saw because the hoop is 44. This is 1.5 inch, which is 38mm. So very important that when you start notching the other tubes to suit onto this tube, you need to change your hole saw from a 44 to a 38 if you're using 1.5 inch tube. The line that I marked is lined up with the V on the clamp and the notcher. So now we just sit there with a drill, turn that, wind it on, make it go forwards obviously. So I've just run a weld around the inside of the stays at the top of the hoop after tacking the stays to the bottom of the base plates. Next thing I want to do is run a slash or an X brace in the rear stays. So before I do that, I need to terminate the rear harness bar. Under Schedule J in CAM's regulations, that termination of that crossbar or the harness bar has to be within 100mm of the base plate. So I measure from the back of the tube up 100mm, and then I draw a line around the back of it, and then that's where I sit the back of this tube onto the rear stay. So I measure from the inside of this tube where you want to terminate it to the outside of this one, and that's how long I cut the tube. The reason for that is by the time you notch it, this section of the notch should be a little bit under halfway, so it's probably 1/3 of the way through. So you've then got about 5mm on each end to fine tune it to make it fit. Find that angle, literally just sit that on there, push across till it comes in, and that's pretty much bang on 90 degrees. So I didn't even have to change the notcher for that. So I notch that end, I leave this end sitting on top of the tube, I line it up with my pen mark on the back, and then I get my pen and then pretend this tube is sitting on top of here, not where it is now, and then I just eye up the edge of that tube and I'll draw a line on it, and that's where I run the notcher through. That tube there fits perfect, and the more you do it, the faster you get, and you'll get to a point where you don't even have to think about it really. You're just notching tubes and smashing them out. So I'm going to repeat all those processes. I'm going to weld that tube out as much as I can inside the car, and then I'm going to put an X brace in it using those same techniques. Building the front legs is a little bit tricky. It just takes a little bit of practice to get it right. You need to have a little bit of an eye for it. There's a couple of different ways you can do it. So a lot of cage builders actually build the cage so it's super tight on all aspects of the body. So to be touching in between the B pillar and the A pillar all the way across here, it'll then be touching the A pillar all the way down, then down into the foot. I like to leave a pretty decent gap in between the front windscreen and front leg, so that way then I can put a decent sized dimple die gusset in there, because the aesthetics of that I think look better than having the cage right on the body. What I've realized is the body of this 86 has a few different curves. Nothing's dead straight. It's actually quite difficult to do these front legs, and the reason for that is this foot plate down here is actually in from the body, so the whole car tapers inwards as it goes down, and then this A pillar has a nice bend in it. That's probably got, like, if you were to draw a straight line from here down to there, there's probably like a good 40mm between here and where that straight line would be. You then come up into the roof, and this has a nice curve in it as well, and then because of where the hoop is, so I've got to because I've got to tilt the hoop forward with the front legs on it in order to weld up and over the top of the front legs. They'll be up here somewhere. It's going to make those quite difficult to do. The way I do it is like this. I get my test bend, I chuck it up on the roof, I move it forward until it hits that part of the roof. I then imagine the back part of that tube, I'll then clock it like this until I'd imagine that looks like it's going to line up with the cage. I want this to be as high as possible and up on that seam of the roof. You can actually see this seam of the roof here sits like 10 mil lower than that actual roof. What I've done then is I've got my digital angle finder, I've sat that up in the roof, I've imagined roughly where that tube's going to go down to, and when it hits this part of the roof brace, it actually gets in the way. By the time I've got to move that back to make it fit, your leg's going to be way down here somewhere because it has to bend from up there in the top of the roof. The higher you go into the roof, the closer to the driver's head it is. The more out of the way of the driver's head, it then gets into the part of the side of the head where if you have a big accident, you're going to kind of break your neck. So you want to make it, if you had a side hit and your head moves, it's not going to hit the cage. What I've worked out is I'm going to put a bend up here somewhere that then comes down to meet the cage. It'll then be solid up against this ridge here in the roof. I've then taken a notch out of this part of the roof brace so the tube can sit right up in there and go all the way up until it touches here, and then it'll run down and then into that foot plate. Test piece comes up, it comes forward, you draw a line, which is what I've done up there, and then I do the same thing down here. I want to kind of imagine how this is going to sit as it runs kind of up like that, somewhere roughly there. I'll just imagine that bend's going to come across and keep coming down until it meets that. I've got my little mark here and I've got my little mark up here. So then what you can do, if you want to work out, well, how do you know what the distance is between here and down there, because you've got two bends and then you've got an offset as well. That's what this thing's good for, because then what you can do is you can imagine, you can flip your test piece over and you go the opposite way. So you pretend like that's going down the A pillar where you want it and you move it back, and then you can put another line here, and then you can measure from this line to that line down there, and then you've got a measurement between your bends. You use your digital angle finder, you find out what that is, you do that bend first. It doesn't matter how it sits in your bender, it's going to bend it straight anyway. You do that bend and then you put your test bend upside down back to back on your bend like this. This is your leg, right, that I've bent up. So you've got your bend here, and then you flip this over so it sits like this and you match your radius up. You can then draw a line here, and then you can measure from here down to the start of your next bend. That's how you know where the start of that next bend is going to be. You then need to work out how you measure the offset. You can see up there how the leg goes out on an angle, and this one here is perfectly straight up and down. I always just measure dead straight across the top of the window, because you know that's always level, and then down to this angle down here at 90 degrees. Because you know that your leg is pretty much going to be 90 degrees. It goes across the roof, it comes down, and then it comes down here. So you know that that part there and that part up there is 90 degrees. So when you do your first bend, when you bend your second one, that's all you really have to look for in your bender. You can do as much mass as you like, but you can even get it by eye if you really wanted to. You can see I've got the other leg roughly sitting in position over there where I've bent it down to sit it in there. I've got to notch a little bit more out of that and finesse it to make it fit good, like that, and then draw your line until this edge here lines up with your foot plate down there. And that's it, that's how your front leg's going to be. That will then give you a measurement, so 106. So take that off 90, that makes 16, so you know that that leg's going to be bent at 16 degrees. A way that you can do that is there's a simple tool you can buy off Speedworks actually. I've got it just here. I've gone on Alibaba and I've got one of these little Chinese digital levels. You just turn it on, it just tells you in degrees what way you are. Clamp that onto your tube and then you just set your digital level on there. And then you set that up so your first bend is perfectly up and down like that, and then you just clock this until it hits 16 degrees, and then you do your second bend, and then you know that this leg and the other leg that gets bent in the car are going to be identical. That's the entire cage welded in as much as I can get to in the car. I've got most of the way up and around the top of the front legs actually, so I should only have to weld 15-ish mil over the top of it and then it'll be done. What I'm going to do now is cut the tacks, bring the cage forward, try and pivot it down so I can get up and over the top of the front legs. In order to do that, I'm going to pull the boxes out because I've only tacked them in. So I'll show you what I mean. I've only got a tack here and then a tack there. That's all holding those boxes out, so I'll pull those out, then I'm hoping that it will just rock forward, cage will drop down. I can then weld on top of these here and here, and then over there and there. And then there's a tiny bit underneath that back harness bar that I need to tack in. The front intrusions, I've run a NASCAR style. They're fairly low. The reason for that is where you've got the seat and it sits, the seat actually sits quite low in this car, which is good because it's like almost as close as you can get to a flat floor. The top of the apron on the seat is roughly about here. I always run this style bar instead of an X, and the reason for that is as you're sitting in the car and you're steering, your elbows tend to hit the X bars unless you put a bend in them and bend them up and bend them down. Another reason as to why I do these is when you're sick. Another reason as to why I do these is when you're getting in and out of the car, there's heaps of room here for your legs to get in and out, but there's still enough support structure there if you were to have a big side-on hit. The top of this bar is right at hip height, so it's where it gives you the most protection if you were to have a big side hit. I've bent the bottom of that leg up to match the top one so I can get underneath it to weld it, and I can still weld the base plates in on the hoop. Another thing is I've brought the front legs in. The reason for that is that the customer for this car wants to keep their door cards, and the door cards are quite beefy, so I've had to bring them in, but that's alright because I like making big dimple die gussets anyway, so it'll look sick no matter what. I'm pretty happy with the fitment. It's touching the roof in a whole bunch of places. Top halo bar, it's nice and tight as well. As long as I can tilt it forward now, we are all good. So I'll do that and then we'll get some shots of it being finished. That was a whole lot more painful than what I originally estimated it to be. So the issue that I had was as I dropped the cage forward, I couldn't actually get it out of where it's lodged in. Like with this being tight and everything up in here, and it's super tight all the way along the roof line, like there's no room in that at all. As I dropped the front foot down, I couldn't get the cage forward. It ended up getting stuck in here, and then I couldn't get the cage forward enough to be able to drop it down into there. So it was really tricky to weld the top and the back of that there. So what I had to do is get a ratchet strap from underneath that door bar and underneath that one and close the cage up, which normally you do anyway to be able to get it down and in the hole to weld it, but I had to do it a whole lot more than what I wanted to. That's also a good trick that you can use to weld the back of your intrusion bars. So that bottom one I managed to weld all the way around it before I bought the cage for, because it's got this void here, whereas this one here you've got no hope, so you have to squeeze the cage, and then this hoop ended up being like in here somewhere, so I had heaps of room to dig around the back of it. I finished off the boxes, I've ground them so they're all pretty. I've welded the front boxes back in, the cage is in its final position, it's fully welded in now. It looks really good. So the last two bars I got to put in, I just put that harness bar in there as I just showed you. So the last one is to put the seat back in and work out where the dash bar is going to go, so then that way I can mount the steering column back to it. And then after that it's just the dimple die gussets that go up here in the A-pillar, and we're good to go. That's the job finished. That's the cage finished in this GT86. Baxter's going to come and pick it up tomorrow morning. I've just quickly etch primed as much of the bare metal as possible. A-pillar gussets are all finished. I've just finished the steering column mount, which is just a flat bit of 3mm sheet. I've just folded the outside edges, cut it on a taper at the top, and then ground a semicircle out of the front where it's been folded to go around the dash bar. It turned out super good. I'll put 2 countersunk bolts in from the top down and then put 2 plug welds on each side of them to hold them captive. That concludes this episode. Sorry if I've rambled on. It's just there's a fair bit of information involved with building a cage. Thank you very much for watching. Remember to like, subscribe, hit that bell thingamajiggy. It helps me out heaps. And I appreciate all of you for coming along on the journey. Stay tuned because we've got more coming in. See you soon.